Hear that? It's the sound of two dying black holes. It's the sound of 1 billion years ago. It's the sound of the invisible. On February 11, 2016, one of the biggest discoveries in science was announced. The LIGO Observatory detected gravitational waves 100 years after they were predicted by Einstein's general theory of relativity. One of the most fascinating things about Einstein was that his theories came from his imagination. He would fall into dreamlike reveries, thought experiments, like what would happen if you actually tried to catch a beam of light. The main difference between Einstein and the rest of us was that he could change these thought theories into actual mathematical formulas. Although when you think about it, math kind of is imagination. Einstein's general theory of relativity has been verified over and over again. Each one of its theories have been observed and confirmed, except one: gravitational waves. No longer. After 100 years, the world has finally caught up with Albert Einstein. Gravity is weird. Gravitational waves are really weird. Most of us think of gravity working kind of like magnets, with things being pulled towards each other, but that's not really correct. Einstein figured out that gravity is distortions in space-time by mass. The cliché and kind of creepy analogy goes like this. First, I'm gonna need you to fire up your imagination, which shouldn't be too hard for you stoner scientists. Imagine a giant rubber sheet. Why a rubber sheet? Nobody uses rubber sheets. And place a bowling ball in that imaginary rubber sheet. Notice how the sheet stretches around the bowling ball, kind of how space-time is distorted by mass. Now imagine placing a marble on that sheet. Notice how it seems to be attracted to the bowling ball? Congratulations, stoner scientists! You've just imagined gravity. Well, at least a 2D approximation of it. Now, imagine placing a manatee on that rubber sheet. Whoa, that's a crazy distortion. Imagine noticing ripples in the rubber sheet as that manatee gets dropped on it. Good job, stoner scientists! You've just imagined gravitational waves. Now, in our universe, it takes something pretty major to create those gravitational waves, the way that a manatee disrupts a rubber sheet. But every now and then, these events do happen, sending tasty gravitational waves zooming through space-time. Events such as two supermassive black holes merging and devouring each other. That's what LIGO detected. But even when these gravitational waves are coming off of supermassive black holes, they're still really small, like 4/10,000ths the diameter of a proton, which is, take it from me, really, really, really small. And if that didn't make them difficult enough to detect, they're also invisible. And that's a problem. You see, every scientific, astronomical discovery we've made to date has been based on light. Which makes sense, that's how humans see. But the universe doesn't care what humans need to see. Gravity don't need no stinking light. So, how do we see something we can't actually see? Don't despair, stoner scientists. It turns out we can hear them instead. These gravitational waves make sound. What LIGO did was create two huge L-shaped detectors, one in Louisiana and another in Washington State. The idea being that LIGO would shoot a laser beam and split it, each half going down a 2.5-mile tube. The beam would hit a mirror and then go back to the splitter thingy, moving at the speed of light, as light does. These two beams would converge and dissipate. No visible light left to be seen, unless a gravitational wave were passing by. The gravitational wave would shorten one tube and lengthen the other, so these laser beams would get all messed up. One would be longer and the other shorter, so when they got back to this glitter thingy, they wouldn't converge. There would be a gap between them. And detecting those gaps is when LIGO springs into action. It records the frequency of that gravitational wave, a little audio chirp. And that's exactly what happened on February 11th, 2016. We can learn a lot about the universe from these gravitational waves. Each wave has its own unique chirp, a sound that's like its fingerprint. And using computer models, we can figure out exactly when, where, and what created that chirp. That's how we know the wave that LIGO detected was from two merging black holes 1.3 billion years ago, creating the energy of 100 supernova explosions, all from one gravitational wave. Using this method, we could figure out what neutron stars are, maybe figure out if the strings from string theory really exist, perhaps even hear the Big Bang itself. It's like science got a third ear instead of a third eye, and can now hear things we could never before imagine. Who knows what unimaginable mysteries the universe will reveal to us? Although, pretty sure there aren't too many cosmic mysteries you can't imagine, stoner scientists.